Good day, viewers. My name is Dr. Chris Isekaibe. I welcome you to my YouTube channel today again. I want to please plead with you to subscribe to my YouTube channel, Dr. Chris Isekaibe. It's a channel where I teach statistics and mathematics topics. I believe as you stay through the end of this class, you will be able to capture or understand what today's topic is all about. The last video I posted, we looked at how to calculate the range, the quartile deviation, the mean deviation, the standard deviation, and the variance. In statistics, this topic is what we call the measures of dispersion. The range, the quartile deviation, the mean deviation, the standard deviation, and the variance are all measures of dispersion. Some authors call it measures of variability. So we looked at these measures on grouped data in our last video. Today we shall be looking at it for grouped data, how to calculate the range, how to calculate the quartile deviation, how to calculate the mean deviation, how to calculate the standard deviation, and how to calculate the variance for grouped data. Group data are data that have class intervals and frequencies. When data are bulky, when data are large, we group them. So this is a sample of 40 observations that were grouped into this frequency distribution table. So today we shall be making use of this table to calculate the range, the quartile deviation, the mean deviation, the standard deviation, and the variance. Please be patient, stay through the end of this class so that at the end of it all you will gain knowledge. Please share my videos on your social media platform, on your WhatsApp status, your Facebook, your Instagram. Please just share the video because it is good to share knowledge, and when knowledge is shared, it goes globally. Today we are taking these measures one after the other for grouped data. Number one we shall be looking at is the range. The range is denoted as capital letter R. So here, for grouped data, you need to look at the lowest class. You take note of the lowest class. The lowest class here, we are not taking it from the class boundaries. We are taking it from the raw class interval. So the lowest class is 1 to 5. Then we take note of the highest class. The highest class is 21 to 25. So this means that by definition, our range is equal to the highest value minus the lowest value. So the range for this set of group data, now for the highest class, you pick the higher value, which is the upper boundary. You pick it, which is 25. Then for the lowest class, you pick the lower boundary, which is 1. So it will be 25 minus 1. So our range for this set of group data is 25 minus 1 and is equal to 24. So the essence why we are not taking it from the class boundary is because the class intervals cover the range of values from the 40 observations. The essence of class boundary is to expand the boundary so that anytime we calculate any of these measures, they will fall into the class where each of them belongs. So that is how the range is calculated. The range for this set of data is 24. Now it is also useful that we calculate what we call the coefficient of the range. So the coefficient of the range is COR is equal to the highest value minus the lowest value all over the highest value plus the low value. So this will be 25 minus 1 all over 25 plus 1, and that will be 24 over 26. So the coefficient of the range is 24 over 26, and that is equal to 0.92 to 2 decimal places. Remember, in our last class we considered the advantages and disadvantages of the range. So I will encourage you to go and watch that video, the part 1 of how to calculate the range, the quartile deviation, the mean deviation, and the standard deviation, the variance inclusive. Watch that video again and see how you can understand the range better by studying the advantages and disadvantages of the range. It was explained very well in that video, the part 1 of this video. This is part 2. So now we want to look at the quartile deviation. Permit me to clean the board. This is how the range is. The range is 24. The coefficient of the range is 0.92. Please take note of this. So we have calculated the range. Now we want to calculate the quartile deviation. Like I said, we are taking them one after the other. The quartile deviation is known as QD. Is known as QD and is equal to Q3 minus Q1 all over 2. That is what the quartile deviation is. That is the formula for calculating the quartile deviation. Now we will look at how to calculate the Q3. You know, the quartile is sharing the data set into 4 equal parts. Q3 is the third quartile, while the Q1 is the first quartile. So our Q3 is given by this formula: L plus 3 summation F over 4 minus the cumulative frequency before that class all over the frequency of the third quartile class times C. C here is our class size or class weight. Now, the first thing we need to do is to know the class where the Q3, the third quartile, falls. So we are going to have, this is our, remember in our video I talked on quartiles, this is our determinant, 3 summation F, we call it class determinant, is equal to 3 times, our summation F is the sum of the frequency, which is 40 all over 4, and that will be 120 over 4, and that is 30. So where does 30 fall? It will interest you to know that 30 falls under this cumulative frequency class from 15.5 to 20.5. It has left 29, so 30 is above 29, so it falls within this class of 35. So our Q3 class is equal to 15.5 to 20.5. Now, what do we need to calculate the Q3? Here, our L is equal to 15.5. Our cumulative frequency before that class, is 29. Then, of course, our frequency of the Q3 class, the frequency of that class is 6. Then, of course, our class size, our C, is equal to 5. Look at it, you will see it clearly from the class boundaries. 5.5 minus 0.5 is 5. Here, 1 to 5 is 5. 1 inclusive. 1, 2, 3, 4, 5. 6 to 10 is 5, 6, 7, 8, 9, 10. So our class width is 5. Now we can calculate our Q3 from here. Our Q3 will now be equal to L is 15.5 plus 3 summation F over 4 is 30 minus the cumulative frequency before that is 29. The cumulative frequency, this is the Q3 class. The cumulative frequency before it is 29. All over the frequency of that class is 6 times 5. So you come here now, our Q3 will be equal to 15.5 plus 30 minus 29 is 1 all over 6 times 5. This will be equal to 15.5 plus 5 over 6 is equal to 15.5 plus 5 divided by 6 is 0.83. 0.83 to 2 decimal places. So this now means that 15.5 plus 0.83, our Q3 will now be equal to 16.66. It will be 16.33. 16.33. So our Q3 is 16.33. Please take note of that. Now we are going to calculate our Q1 because our quartile deviation, for us to calculate it, we need our Q3 and our Q1. So let's go ahead and calculate our Q1. Permit me to also claim the Q3. I hope you have taken note of it. You have taken note of the Q3. So you can see that that value we just calculated falls within the Q3 class. Now our Q1 is equal to L plus summation F over 4 minus cumulative frequency before the Q1 class all over the frequency of the Q1 times our class width. So we need to know the class. Our Q1 class will be summation F over 4, that is 40 over 4, and that is 10. So for us to have 10, where does 10 fall? We trace these classes or each class from the cumulative frequency column. That is the essence of the cumulative frequency. It helps us to trace the class. This 10, where does it fall? The first value here is 6. Of course, you know how we got our cumulative frequency. You put the first one 6. 6 plus 8 is 14. 14 plus 15 is 29. 29 plus 6 is 35. 35 plus 5 is 40. And this must tally with the total frequency. The total frequency is 40. Now the cumulative frequency helps us to trace the class where each of these measure of position belongs. Now 10 is above 6. So once it is more than 6, it falls in the second class. Between 6 any value above 6 to 14. So this will now be our Q1 class. Note we use the class boundaries. So our Q1 class is equal to 5.5 to 10.5. So when the Q1 is calculated, it must fall within this class. The value must fall within that class. So from here we can get everything we need. Our L is equal to 5.5 is the lower value of the class. Then our cumulative frequency before that class, remember this is the class, so the cumulative frequency before it is 6. Then our frequency of the Q1 class, the frequency of that class is 8. And again, our class size is 5. So we'll now come here and calculate our Q1. Now our Q1 will now be equal to, our L is 5.5 plus summation F over 4 is 10. That's what we got here. 10 minus the cumulative frequency before that is 6 all over the frequency of that class, which is 8, then times 5. So our Q1 will be equal to 5.5 plus 10 minus 6 is 4 all over 8 times 5. So this will be 5.5 plus 4 times 5 is 20 over 8. So this will be 5.5 plus 20 divided by 8 is 2.5. 2.5. So 5.5 plus 2.5, that means that our Q1 is equal to 8. So please take that. Take note of that. Our Q1 is 8. Now that we got our Q3 to be 16.33 and our Q1 to be equal to 8, we can now go ahead and calculate our quartile deviation. So our quartile deviation, permit me to also clean this. Our quartile deviation is Q3 minus Q1 all over 2. Q3 minus Q1 all over 2. So it means that our quartile deviation will be equal to our Q3 is 16.33 minus 8 all over 2, and that is equal to 16.33 minus that will be 8.33 all over 2. So our quartile deviation, when you divide 8.33 by 2, you are going to have 4.17 to 2 decimal places, 4.17. So that is our quartile deviation. Now we want to look at what we call the coefficient of the quartile deviation. Note, each of these measures of dispersion has a relative. So the relative of the quartile deviation is what we call the coefficient of the quartile deviation. So that will be given as the coefficient of the quartile deviation, and that is given as Q3 minus Q1 all over Q3 plus Q1. That is the formula for calculating the coefficient of the quartile deviation, and this will be equal to our Q3 is 16.33 minus 8 all over 16.33 plus 8. So our coefficient of the quartile deviation will now be equal to, you take away that from, you take 8 away from that, you are going to have 8.33 all over, you add 16.33 to 8, you have 24.33. So our coefficient of the quartile deviation will now be equal to 8.33 divided by 24.33, and that will give us 0.34. So our coefficient of quartile deviation is 0.34, while the quartile deviation itself is 4.17. So that is all about the quartile deviation for this problem. Remember, in the first video we talked extensively about the advantages and disadvantages of the quartile deviation. Please watch that video again and understand the advantages and disadvantages of the quartile deviation and how it works. I believe if you do that, you will be able to understand the topic better and how the quartile deviation is applied. You will see its drawbacks, its advantages, and so on and so forth. So the third on the line is our mean deviation. Please note, our mean deviation has three parts. It has the mean deviation about the mean deviation about the mode, and the mean deviation about the median. The mean deviation about the mean deviation about the mode, and the mean deviation about the median. So let's go ahead and calculate our mean deviation. So we'll look at these three aspects: the mean deviation about the mean deviation about the mode, and the mean deviation about the median. Now, before we calculate the mean deviation, we will first of all have to calculate what the mean, the mode, and the median. So we are looking at the mean deviation. Now, before we calculate the mean deviation, let us see how we can calculate first of all, because the median is also a measure of position. So we can calculate the median since we already have the class boundaries and the cumulative frequency here. So now let's calculate the median. The median is given by this formula: L plus summation f over 2 minus the cumulative frequency before that class, all over the frequency of the median class times C. So we need to know the median class by getting, we have to use this class determinant, summation f over 2, and that is 40 over 2. Our summation f is 40, that will be 20. Now where does the median fall? This is 6, of course, 20 is above it. This is 14, 20 is above it. So the median falls here. So it's higher than 14, but it's between that a value above 14, between that and 29. So our median class will be equal to 10.5 to 15.5. So the things we need, our L, which is the lower class, will be 10.5, the lower value for that class. Our cumulative frequency before that class, which is 14. Look at the class here. 14 is above it, so it's 14. And the frequency of the median class is 15. Frequency of the median class is 15. And again, our class size is 5. So we are going to put these values together to get the median. So coming here now, we will now have our median to be equal to, the class is 10.5 plus summation f over 2 is 20. 20 minus the cumulative frequency before that class is 14, all over the frequency of the median class is 15, then times our class width times 5. And this will now be equal to 10.5 plus 6 over 15 times 5. Because 20 minus 14 is 6. So our median is equal to 10.5 plus 6 times 5 is 30. 30 over 15, that is equal to 10.5 plus 2. 30 over 15 is 2. 10.5 plus 2, that will be equal to 12.5. So our median is equal to 12.5. So please take note of that. Our median is also the second quartile. So our median is 12.5. Let us take good note of that. Now we'll go ahead and calculate the mean and the mode. So permit me to clean this part of the board. I want to go ahead and calculate the mean and the mode so that we can come ahead and calculate their various mean deviations. Now, for me to calculate the mean and the mode, I don't need the cumulative frequency any longer, and I don't also need the class boundary. So permit me to clean this part from the board. The cumulative frequency is no longer needed, and the class boundaries, of course, will be needed for the mode. When we get there, we will make use of it. Now we want to get our mid values x. Our mid values x, because our mean is equal to summation f of x all over summation f for group data. So now we get the x, which is the mid value, from the classes or class interval. Between one, the cheapest way to get it is add the two, the upper and the lower, and divide by 2. 1 plus 5 is 6. 6 divided by 2 is 3. 6 plus 10 is 16. Divided by 2 is 8. 11 plus 15 is 26. Divided by 2 is 13. 16 plus 20 is 36. Divided by 2 is 18. 21 plus 25 is 46. Divided by 2 is 23. Now we are following this formula. We are going to get another column, which is f of x. So our f of x simply means you are multiplying the frequency by the mid values x. So 6 times 3 is 18. 8 times 8 is 64. 15 times 13 is 195. Then 6 times 18 is 108. Then 5 times 23 is 115. So you add all this together, 18 plus 64 plus 195 plus 108 plus 115, it gives you 500. So our mean is equal to the summation f of x is 500, which is 500 all over. Summation f is 40, which is the sum of the frequencies, is 40. So our mean is equal to 500 divided by 40. Our mean is equal to 12.5, the same value with the median, 12.5. So our mean is 12.5. Also note that our median is 12.5. Now let us calculate our mode. Our mode is equal to L plus F0 minus F1 all over F0 minus F1 plus F0 minus F2 all times the class size or the class weight. Now it is good we know the modal class. How do we detect the modal class? We detect the modal class from the highest frequency. So this is the highest frequency. So the modal class will be equal to, it falls between 11 to 15. So we are taking the class boundaries. It will be 10.5 to 15.5. We are taking the class boundaries, that's what we use. So here our L will be equal to 10.5, the lower part of that class, the lower value of that class. Then our F0, F sub to 0 is the highest frequency itself, which is 15. Then our F subscript 1, which is the one before the modal class, the frequency before the modal class, that is 8. Then our F2 is the frequency below the modal class. This is the frequency of the modal class, which is 15. The one above it is F1, the one below it is F2, so F2 will be 6. So we can now come here and calculate our mode. So the mode that we calculate, the value must fall within this class. 10.5 to 15.5. So our mode is equal to, our L is 10.5 plus F naught is 15 minus F1 is 8 all over F naught is 15 minus 8 plus our F naught is 15 minus F2 is 6, then times the class weight times C. Permit me to move further. This will be 10.5 equal to 10.5 plus 15 minus 8 is 7 all over 15 minus 8 is 7 plus 15 minus 6 is 9 all times 5, which is our class weight. So our mode is equal to 10.5 plus 7 all over 7 plus 9 is 16 times 5. So this will be equal to 10.5 plus 35 over 16 is equal to 10.5 plus 35 divided by 16 is 2.19. So 10.5 plus 2.19 is 12.69. 12.69. So our mode is equal to 12.69. Our mean is 12.5. Our median is 12.5. Our mode is 12.69. Now that we have gotten this, we are now going ahead to calculate the mean deviation about the mean deviation about the mode, mean deviation about the median. Permit me to clean this part of the board. Take note, our mode is 12.69, our median is 12.5, our mean is also 12.5. Now we are going to remove this part of the board because we are not going to need it for our mean deviation. Now let me write out the mean deviation about the mean. Now the mean deviation about the mean is mean deviation about the mean is given as MD is equal to summation F absolute value of X minus X bar all over summation F. So that is what we are going to need to create the table. That is what we are going to need to create the table. Remember, our X bar is equal to 12.5. It was calculated. So we'll create a column here. We call it X minus X bar absolute value. The absolute value erases the negative sign. That is one major drawback, one major disadvantage of the mean deviation. Please, for you to understand the advantages and disadvantages of the mean deviation, visit my last video. It was very well explained there. So now we need the X minus X bar in absolute value. Now, okay, before we take that, let us quickly also write the value of X. Let us write again the value of X. X is our mid value, so it is necessary we have it here. So we have our X. Again, our X is 3. 1 plus 5 is 6 divided by that 3. 6 plus 10, 16. 8. 11 plus this 26 divided by 2, 13. Then the next one is 16 plus 20, that is 36, divided by 2 is 18. The next one is 46, divided by 2 is 23. You will see the difference here in the class width. 8 minus 3 is 5, 13 minus 8 is 5, 18 minus 13 is 5, 23 minus 18 is 5. So you will see the class size right there in the value of x. So we can now come and create another column for x minus x bar in absolute value. Now you will see it. The first value of x here is 3 and our x bar is 12.5. So 3 minus 12.5 is supposed to give us minus 9.5, but because of the absolute value, the minus sign will go, so it will write 9.5. Then the next one is 8 minus 12.5 is supposed to give us minus 4.5, but because of the absolute value, the negative value will go right 4.5. The next one is 13 minus 12.5. Of course, that one will give us 0.5. Then the next one is 18 minus 12.5. That one will give us 5.5. Then the next one is 23 minus 12.5. That will give us 10.5. Now the next one is multiplying it by f. So you're going to have f into absolute value of x minus x bar. So you have that. Now what are we doing? We are multiplying this. We are multiplying this by the frequency. So 6, the frequencies, look at the frequencies here. Then we are multiplying this column, which is this x minus x bar absolute value, by the frequency. So 6 times 9.5, 6 times 9.5 will give us 57. Then the next one is 8 times 4.5, that will give us 36. Then the next one is 15 times 0.5, that will give us 7.5. Then the next one is 6 times 5.5. 6 times 5.5, that will give us 33. And the last one is 5 times 10.5, that will give us 52.5. You add all these together, 57 plus 36 plus 7.5 plus 33 plus 52.5, you are going to get 186. So our main deviation about the mean will now give us, look at the total value here, 186 over 40. So the main deviation about the mean will now give us, 4.65. 4.65. That's the main deviation about the mean. So now let us calculate the coefficient of the mean deviation about the mean. So coefficient of the mean deviation about the mean, now that is given by the mean deviation divided by the mean, because it was calculated from the mean. So it will be the mean deviation MD all over the mean, and that will be equal to the mean deviation is 4.65 all over the mean is 12.5. So the coefficient of the mean deviation is equal to 4.65 divided by 12.5. That will give us 0.37 to 2 decimal places. You can see that. That will give us 0.37 to 2 decimal places. I want you to note that since the mean and the median are the same, it simply means that the mean deviation about the median will also be 4.65, because note, we know that the median when we calculated is 12.5, and this is equal to the mean. So that means their mean deviation will be the same, and their coefficient of mean deviation will also be the same. So it will be the same for the median. The mean deviation about the median will be 4.65, as equal with the mean, because they have the same value. Then the coefficient of the mean deviation about the median will also be 0.37. It is only the mode that is a bit different. The mode is 12.69, which is not too different from the mean and the median. So the mode again is 12.69. You can see how close they are. So the mean and the median are the same. The mode is just a very little, so they are almost the same. If you round up, they are almost the same. So this means we are going to calculate the mean deviation about the mode. So let's go ahead now and calculate the mean deviation about the mode. Since the mean deviation about the median and the mean deviation about the mean are the same, because the mean and the median are the same in value. They are the same in value. So now we are looking at the mean deviation about the mode. So mean deviation about the mode. So the mean deviation is given as MB is equal to summation F absolute value of X minus mode, all in absolute value, all over summation F. So we are going to recreate another table that has to do with the mode. So permit me to clean this one that we use for the mean. So we are going to create another table for the mode. So now we are going to write our X minus mode in absolute value. Remember, our mode is 12.69. So the first value of X there is 3. 3 minus 12.69 is minus 9.69, but the absolute value takes care of that, so you have 9.69. Then the next one is 8 minus 12.69, that will give you minus 4.69, but the absolute value takes care of that, so you're going to have 4.69. The next one is 13 minus 12.69, and that will give you 0.31. 0.31. The next one is 18 minus 12.69, that will give you 5.31. Then the last one is 23 minus 12.69, and that will give you 10.31. So we are going to create another column here. This one will be F this one will be F into X minus mode absolute value, not into absolute value. So we are using this to multiply the frequency. The frequencies are 6, 8, 15, 6, and 5. Then these are the values. That's what the formula demands. So 6 times 9.69, it will be 58.14. 58.14. Then 8 times 4.69 will be 37.52. Then the next one is 15 times 0.31 will be 4.65. Then the next one will be 6 times 5.31, that will be 31.86. Then the last one is 5 times 10.31, that will be 51.55. 51.55. Please note, all these are done in 2 decimal places. Now when you sum this, you add them up, you are going to have 183.72. 183.72. So our mean deviation about the mode will be equal to, all this will now be 183.72 all over 40. So our mean deviation about the mode, 183.72 divided by 40 is 4.59. 4.59. 4.59. Do you see that? Then the coefficient of the mean deviation about the mode, the coefficient of MD about the mode will be equal to, so the coefficient of mean deviation about the mode will now be the mean deviation itself, mean deviation all over the mode, and that will be equal to, the mean deviation is 4.59 all over the mode is 12.69. 12.69. So our coefficient of mean deviation about the mode, 4.59 divided by 12.69, that is equal to 0.36. 0.36. You can see how close they are. You can see how close they are. Permit me, since the median is equal to the median is equal to the mean, and their mean deviation is equal to 4.65, and their coefficient of the mean deviation is equal to 0.37. Now look at this one. For the mode, the mean deviation is 4.59, and the coefficient of mean deviation about the mode is 0.36. Look at the closeness. You can see how close the mode and the mean and median are, 12.5, 12.69. So this one, 4.65. Look at it here, 4.59. This one, the coefficient of the mean deviation about the median and about the mean is 0.37. Then the coefficient of the mean deviation about the mode is 0.36. So you can see how close they are. This is how we calculate that. So now the next one we shall be looking at is the variance and the standard deviation. These two go together. We talked a lot about the advantages and the disadvantages of the standard deviation. The standard deviation is the best measure of dispersion. If all the values are constant, if they are the same, the standard deviation is 0. So it is very reliable. It is very, very easy to understand, and again, it is also useful for further mathematical calculations. Now we shall be looking at the standard deviation and the variance. The standard deviation and the variance, permit me to clean the board, please. The standard deviation and the variance, of course, all this will no longer be useful. All this will no longer be useful. Of course, we are going to get a new table. We are going to get a new table. We're going to get a new table. Going to get a new table. So now we need to have the values of x. We have to get our x. We have to get our f. Remember, our x the mid values. We have it as 3, 8, 13, 18, and 23. Please subscribe to my YouTube channel, Dr. Chris Esekaibe. Click on the bell button so that each time I post a video online, you will have a notification. Share my YouTube videos on your social media platform, your Instagram, your Facebook, your WhatsApp status, various WhatsApp platforms. Share them, be part of those sharing knowledge, and as you do, God will bless you. So again, let's continue. Our frequency is 6, 8, 6, 8, 15, 6, and 5. So now, the formula for the variance is very simple for group data. Now we are looking at the variance. So the variance is, we call it VAR is equal to summation F into X minus X bar all squared all over summation F minus 1 for sample. If it is for population, it will just be all over summation F. I talked about that in our last video. So when you are dealing with this, the population is just summation F. 1 is not subtracted from the denominator. But if you are dealing with a sample, of course 1 is subtracted. So now we are going to follow this to get our variance. The first thing we need is our X minus X bar. We'll go ahead and square it right away. Note please, our X bar is equal to 12.5. As calculated, is the same data set we are dealing with. Now the first value of X there is 3. 3 minus 12.5 again is minus 9.5. 9.5 square. 9.5 times 9.5 will give us 90.25. Now the next one is 8 minus 12.5. It will give us minus 4.5. Minus 4.5 times minus 4.5 is 20.25. Remember, the major advantage of the standard deviation or the variance over the mean deviation is that when you take the square, the minus sign automatically disappears. But for the mean deviation, the absolute value is introduced just to eradicate the negative sign. So this is a major advantage of the standard deviation and the variance over the mean deviation. The next one is 13 minus 12.5. That will give us 0.5. 0.5 square will give us 0.25. The next one is 18 minus 12.5. 18 minus 12.5 will give us 5.5. 5.5 square, which is 5.5 times 5.5, will give us 30.25. Then our next one is 23 minus 12.5. That will give us 10.5. 10.5 square, which is taken as 10.5 times 10.5, will give us 110.25. 110.25. So you can see we are squaring each of them. Then we come now and multiply by the frequency. We are going to have F into X minus X bar all squared. Now the first thing you do in statistics, write down the formula successfully and begin to follow it step by step to create your table. It's as simple as that. So now it simply means F times this, that means you are multiplying the frequency by this particular column. So 6 times 90.25 is 541.5. 541.5. 8 times 20.25. 8 times 20.25 will give you 162. 15 times 0.25 will give you 3.75. 6 times 30.5 will give you 181.5. Then 5 times 110.25 will give you 551.25. 551.25. Now you got to add the sum together because that's what we need for the numerator. You say 541.5 plus 162 plus 3.75 plus 181.5 plus 551.25. That will give you 1440. 1440. So that means that our variance will be equal to 1440 all over 40 minus 1. Remember, our summation f is 40. So this will be equal to 1440 all over 39. So our variance will be equal to 1440 over 39. That will be 36.92. So our variance will be 36.92. That will be our variance. Remember, our standard deviation is equal to the square root of the variance. And so our standard deviation will be equal to square root of 36.92. Square root of 36.92. When you find the square root of 36.92, you are going to have 6.08. 6.08. So our standard deviation for this set of data is 6.08. Now it is also good we calculate the relative of the standard deviation, which is called the coefficient of variation. Now our coefficient of variation that is our COV is equal to the standard deviation all over the mean times 100 over 1. That will be equal to our standard deviation is 6.08 all over our mean is 12.5 times 100 all over 1. And that is equal to 6.08 divided by 12.5, which will be 0.4864. 0.4864 times 100. 0.4864 times 100, that will be 48.64%. So it will be 48.64%. So our coefficient of variation is 48.64%. Beloved, I hope you have learned something today. I told you from the beginning to watch patiently or wait patiently for this video as we run through it. We have successfully done the measures of dispersion for grouped data. We have calculated the range. We have calculated the coefficient of the range. We have calculated the quartile deviation, and we have also calculated the coefficient of the quartile deviation. We calculated the mean deviation. There are the three types: the mean deviation about the mean deviation about the mode, the mean deviation about the median, and their corresponding coefficients of the mean deviation. Now we have looked at the standard deviation and the variance. The standard deviation is 6.08. The variance is 36.92. Now we just look at the relative of the standard deviation, which is called the coefficient of variation, and that is the standard deviation divided by the mean times 100 over 1, and that happens to be 48.64. I hope you have learned this. Please subscribe to my YouTube channel, Dr. Chris. Share my videos there in your social media platforms, your WhatsApp, your Facebook, your Instagram. Just share knowledge across the globe. Let this knowledge keep spreading and spreading and spreading, so that we'll form a community of people that are more knowledgeable in statistics. My videos are classes in mathematics and statistics topics. Once again, I'm a specialist in numerical analysis. I have a PhD in mathematics, a bachelor degree in statistics, a master's degree in mathematics. So my area of specialization is numerical analysis. I also specialize in data analysis and modeling. I also specialize in scientific computing and statistical analysis. I have research interests, financial mathematics, survival analysis, and the rest of them. I'll be bringing us more topic again. In numerical analysis, in calculus, in different parts of mathematics as I'm directed. So please, if you have any challenge in any area of mathematics and statistics and you feel that you want me to teach on that topic and upload the video, why not? Just send me a message. You can put it in the comment section, then I will teach on that topic and upload the video for your sake. We are here to ensure that statistics, the fear that people have in mathematics and statistics, we are here to put that fear behind us. We know mathematics and statistics are cheap, they are easy, they are cheap. All you just need is to focus. Pay your attention and focus on these videos, and you will have better understanding of these various topics. Once again, click on the bell button, subscribe to my YouTube channel, so that anytime I upload a video, you will be among those that will get the notification. Click on the like button, click on the share button, share it in various social media platforms, and as you do, God will bless you, God will increase you. Please be patient again. I'll be coming up with my next video and at any moment from now, and that one will be on numerical analysis. I want to look at the various numerical methods for solving algebraic equations. Numerical method for solving algebraic and transcendental equations. So I'll be looking at them. The method I'll be teaching on is the bisection method. So I'll be teaching on the bisection method, how to use the bisection method to solve an algebraic equation. So please watch out for that video. It will come up within a short time from now, and as you do, God bless you. Once again, subscribe to my YouTube channel, Dr. Chris Isekaibe. Click on the bell button, click on the share button to share the video, my YouTube videos on all social media platforms. As you do, God will bless you, God will increase you. Have a great day. Watch out for my next video. God bless you. Bye.